Hello and welcome to Ratio Lesson 6, the return of scale factors, and we'll be talking more about enlargements by scale factors and how this relates to ratio. Have a look at these shapes. Shape A is 1 unit across the width and 2 units down. Shape B is 2 units across the width and 4 units down. So see if you can fill in the gaps. Shape B is blank, as big as shape A. Shape A has been enlarged by scale factor blank to make shape B. So you can see that shape B is twice as big as shape A, and shape A has been enlarged by scale factor 2. And that is because if you look at the ratios of A to B, with the width it's 1 to 2, and with the length it's 2 to 4. But we know that we can simplify down the ratio of that length, like we would with a fraction, to make 1 to 2. In the previous example, those rectangles A and B are known as similar to each other, which means that they have the same angles. And it also means that one is an exact enlargement of the other. Now here are some more similar rectangles. Rectangle A has a length of 5 centimetres and a width of 2 centimetres. And if we know that rectangle B is similar to that, that means that whatever we scale up the width by, we have to do the same to the length. And the same with rectangle C and rectangle D. So it might help you to draw them, possibly. See if you can work out what goes in the gaps. So pause the video now and have a go. And here are some answers. So you can see that the ratio of length to width in rectangle A is 5 to 2. So we have to keep that ratio with all the other rectangles because they're similar. So with rectangle B, where we have doubled scale factor of 2, we have to double the length as well, scale factor of 2. So that makes that one 10 centimetres. Then from 5 centimetres to 25 centimetres, we've multiplied by 5. Got to do the same thing to the width to keep them similar, so we multiply by 5. And then for the final one, to get from 2 centimetres width to 18 centimetres width, we've multiplied by 9. So we have to do the same thing with the length, multiply by 9. And if you wanted to just double check that they were correct, check that they're still in the ratio of 5 to 2. So if you were to simplify them down as though they were a fraction, you would still get 5 to 2. Here's a reasoning problem for you. A rectangle has a perimeter of 16 centimetres. An enlargement of this rectangle, so it's a similar rectangle, has a perimeter of 24 centimetres. The length of the smaller one is 6 centimetres. Can you draw them both and label them? Pause the video and have a try. Here are my drawings, not particularly exact. So with the first rectangle, I knew that the perimeter was 16 centimetres and the length was 6. So I knew I had to have 2 6 centimetre sides, which meant that my perimeter so far was 12. I had 4 centimetres left to split up over the 2 widths. That was 2 and 2. So now my enlargement has got to have a perimeter of 24. So I've worked out there that I needed to have 2 9 centimetre lengths and 2 3 centimetre widths, because when I add those up together to go all the way around the perimeter, that gives me 24 centimetres. My scale factor that I've enlarged by is 1.5. So it is possible to have a decimal or a fraction as a scale factor. So if I multiply 6 by 1.5, I get 9. And if I multiply 2 by 1.5, I get 3. Here's another reasoning question for you. If I said to you to enlarge a shape, you just need to do the same thing to each of the sides, would that be always, sometimes, or never? Just stop and have a think about it for a moment. And your answer is sometimes. That works if you're multiplying or dividing the sides, but not if you're adding or subtracting to the length of the sides. So your answer is sometimes. This is our last problem. So here are 3 rectangles, 4 units by 2 units, 12 units by 6 units, and 16 units by 10 units. And Ron says these are similar. Do you agree? And why? So have a real close look at the ratios. So no, I don't agree. I think that the orange one is similar to the green one. It's been enlarged with a scale factor of 3. 3 times 2 is 6, 3 times 4 is 12. It's kept the same ratio and it's enlarged by a scale factor of 3. So he's okay on that one. But I disagree on the pink one. The sides haven't been enlarged by the same ratio. To get from 2 to 10 would be a scale factor of 5. But if I multiply 4 by 5, I get 20, not 16. So I disagree with that one, it's not similar. As you can see, the cat has been completely enthralled by ratio lesson number 6. There's one more lesson to be filmed, and I'll do that another day. Bye.